Hi, everybody. Thanks for joining me today. I really appreciate you coming out or staying in, as it were. My name is Trevor, and I am a student as well as a teaching assistant here at Launch School. And today we're going to be talking about working with collections in Ruby. Now, specifically, we'll be looking at kind of the basics of creating, modifying, and utilizing hashes and arrays in code. Now, this is the fourth in a series of recurring Ruby webinars that we're hosting, which are primarily geared towards students that are enrolled in the prep portion of the Launch School curriculum. My fellow TA, Claire, hosted the first three. I'll be hosting this one and then the following two. If you're able to make it to some of Claire's earlier talks, you should have a really solid foundation from which to understand the information in today's presentation. But if you haven't seen Claire's talks, that's totally fine. Even if you're brand new to Ruby or you're not even a developer, maybe you're a systems engineer, I think you're going to find this webinar useful. So let's take a look at what's on the agenda for today. Today, we're going to be looking at what we even mean by this kind of term collections, what the similarities and differences between the different types of collections are, how to create those collections, and then finally how to reference, add, and remove elements from those collections. So needless to say, we are going to be covering a lot of content here, and I'm going to be doing a lot of live demonstrations using a tool called IRB. And then I'm also going to be maybe creating and running some different files as well. If you've never used IRB before, you've never seen somebody use it, all it is just a command line tool that allows you to work with Ruby code without creating and running a whole bunch of different files. So it's just a little bit quicker. Looks a little bit funny, but you will get used to it. I encourage you to kind of type along with me, either in your own instance of IRB or just like in a Ruby file that you have pulled up. That said, if you find that distracting and you'd rather just watch, totally fine too. I'm going to put up some summary slides at the end of each of the content heavy sections, which you're welcome to copy or just take screenshots of. That's probably the fastest, easiest thing to do, just a screenshot. And then additionally, we have some quizzes at the end of each section, which should help solidify the concepts that we're going to be covering. Keep in mind that these quizzes are learning tools. They're not actually assessment tools. Your answers are totally anonymous, so you don't have to worry about getting the wrong answer or anything like that. Additionally, some of the quiz questions reach a little bit beyond what we're going to be covering in the lecture portion. So if you ever see a question and you think like, hey, we didn't really talk about that, you're probably right. And the reason for that is that these quizzes are meant to kind of build on top of the concepts I'll be talking about, and then also encourage you to practice applying those concepts in new, unique ways, rather than just asking you to repeat back to me the things that I just said. Beyond that, I do invite you to use the Q&A function provided on the Zoom toolbar below if you have any questions about anything I say, or if you need me to clarify something or repeat myself. I don't want anyone to get left behind or to get lost because I wasn't being clear, so please just let me know if that happens. That said, I do ask that if you have any more general questions or comments or things that can wait until the end of the talk, I'd appreciate it if you just save those till the Q&A portion, which we'll have plenty of time for at the end. That said, we do have a relatively small group here today, so feel free to just kind of ask questions. This can probably be a little bit more informal, okay? Also, one last thing, you are all muted, and I can't see you, I can't hear you, neither can anybody else. It's just me up here kind of just speaking into the void and assuming somebody's out there listening. So you don't have to have any paranoia about that. So unless you have any questions, I think we can probably get started. No questions? Awesome. Let's get started. So as you can probably guess, the term collection is used to refer to a group or a set of values that are in some way joined or associated with one another. Another way to think about a collection is that it's an object which has other objects stored inside of it. Now, within the context of a coding language, the term collection can be thought more specifically as a structured container for data. Now, depending on who you ask, there are a few different types of objects within the Ruby language that might be considered collections. For instance, some people say that strings are kind of a collection, and other people might count ranges, as in like a range of numbers between 1 and 100. They might say that's a collection. And I think there are valid arguments to be made about all of those and probably a few other ones. But for the purposes of this webinar, I'm going to be using the term collections to refer to the two most commonly used data structures in Ruby, and that is arrays and hashes. So like I said, arrays and hashes can both be thought of as structured containers for data, or more generally as objects that contain other objects. I think that second conception actually warrants a little bit of explanation there. So if you look at the screen here, what you'll see is an array that contains 6 different types of objects. We have an integer, a string, a Boolean, a symbol, a float, and then we have another empty array. And the important thing to appreciate is that this outer array object, denoted by that outer set of brackets, is really just acting as a container for all of these other objects. You can take things out of that array, you can add things to it, you can change the order around, and you'll still have the same array. It's just going to have different contents. That's an important concept. Similarly, if you look at this hash, while the structure is kind of different from our array, and we're going to talk about why that is in just a minute here, you can see that it's also an object that contains other objects of pretty much any type. Again, you can kind of add or remove objects, change things around, and you'll still have the same hash. Now, despite these similarities, arrays and hashes do have some really important differences. So arrays can be thought of as an indexed list of values, while hashes can be thought of as a collection of key value pairs. What I mean by that is that if you look at the array, you'll see a series of comma-separated single values. While if you look at the hash there, you'll see 2 values associated with one another, with each pair itself separated by commas. Now, the first object in that pair is the key, and the second is the value. So in addition to storing those objects, the hash actually keeps track of the association between those 2 things. Further, arrays care about the order of the objects within them, and hashes really only care about the association between the key and the value. So while it's true that current versions of Ruby hashes also maintain their order, once we start looking at how to add and kind of remove and reference objects in a hash, you'll see while the order of objects really doesn't matter very much. And then finally, arrays can contain repeat values, while hash keys must be unique. Okay. So these differences between arrays and hashes are important to keep in mind when deciding which one makes more sense to utilize as a container for data in your code. And in general, if your code cares about the order of the data you're managing, or you need the ability to sort objects based on some kind of specific criteria, then an array probably makes more sense to use. However, if your code cares about an association between 2 values, or your data needs a label of some kind, then a hash is probably better to use. Additionally here, if you're going to be dealing with repeat values, either one can work, but you just need to keep in mind that the keys within a hash need to be unique. Now, that said, there are other factors that you can take into consideration when deciding whether a particular problem calls for an array or a hash. And more often than not, there are going to be more than one way for you to solve a problem. And the approach that you choose can really help dictate which type of collection is more appropriate. Also keep in mind, this is kind of interesting, that both arrays and hashes themselves can contain other arrays and hashes. So this sort of ability to nest collections inside of one another allows you to create and model some really interesting and useful data types. And with that regard, again, there's probably more than one way you can solve the problem, and creativity often works to your advantage. Okay, so with all of that said, we actually have our first quiz already here. And this quiz is going to be covering using arrays versus using hashes in your code. So essentially what I'm going to do is I'm going to present to you a certain sort of like problem, and you're not going to have to write any code, but I do want you to think, oh, which data structure is probably better to model the data in this problem. Now, keep in mind, this quiz is a lot more conceptual than the ones that we're going to get to later. There are probably lots of different right answers, and it's more about thinking through them than getting the exact same answer that I got. So I'm going to put this answer or this quiz up on the screen here. I believe we have 5 questions, and take your time reading them and submitting your answers. All right, we have our first couple answers starting to come in now. All right, we just had somebody come in. There's a quiz on the screen right now. Don't feel like you have to answer it if you just came in. If you want to, take a stab at it, be my guest, but we're going to be wrapping up this quiz. I'm going to say, let's give ourselves another 45 seconds. So for the people out there who are still thinking about an answer, let's try to get some answers down. Like I said, about 30 more seconds from now. And we definitely have a disparity in some of these opinions here. So if anybody wants to try to be a tiebreaker, you have 10 seconds left to do so. 10 seconds to submit your answers. All right, fair enough. I'm going to end the poll and I'm going to post up the results here. And this is actually pretty interesting. So like I said, we have some disagreements here. So let's talk about them, shall we? Okay, so this question number one, here's the prompt. Your program needs to keep track of a bunch of names in a way where they can be sorted, rearranged, and easily deleted or added one by one. Which collection would you use? I think that's a pretty clear use case for an array there. Again, there's a couple of reasons why. We're just dealing with single values, just names. It's not like a name and an age, a name and a social security number. So single values, arrays are suited for that. And additionally, sorting. Again, we said that hashes don't really maintain their order. There's no easy or good way to sort a hash. It really can't be done in Ruby. Therefore, if you need to sort something, you need to use an array. So I think an array is an answer here. It would probably look something like that. Let's look at this next question. You update your program so that in addition to usernames, you also store the user's date of birth. Which collection is more appropriate? Yeah, I agree with the crowd on this one. I think a hash is probably right. Again, because with a hash, the whole point is we have an association between a key and a value. So we have two different pieces of data that are associated with one another. In this case, a name and a date of birth. Here's an interesting potential issue that you will need to consider. What happens if you're dealing with two people who have the same name and you have their names as the key? Or inversely, if you have two people of the same date of birth? That would be something you would need to account for because, again, hashes need unique keys. Okay, just something to think about. Okay, question number 3. You have a program that keeps track of participants in a race. As each participant crosses the finish line, they're automatically added to a collection called rankings. You know that some racers have the exact same name. Which collection would you use? This one, I actually think either one could work. Let me kind of extend our screen here so you can see what we're talking about. There you go. I think you could have a rankings array, and I think that works because, again, we're talking about order, right? So as somebody comes in, you just pop them into the array. That's a pretty good system, and it can account for this sort of repeated names. This Dan Smith here, no problem if you have 2 Dan Smiths in your array. Rankings, I think, could also work because you could just have somebody's rank be associated with their name. What you could not do is you could not have their name as the key because, again, you know that there's repeat values. Another sort of interesting maybe thing to think about here, potential issue you'd want to account for if you were writing this program. What happens if two people cross the finish line at the exact same time? Neither of our data structures here really account for that. So maybe you'd need something that actually recorded their time and not their rank. Maybe, I don't know. Just something to think about. Number 4, you're designing an application for an animal shelter which keeps track of all the people who have adopted pets along with the pets that they have adopted. Some people have adopted one pet while others have adopted several. So we have a nice split in our opinions here. Let's see what I thought about this question. I think either of these would work. I think you could have an array that contains hashes, and I think you could have a hash. Wait, no, I think you could have an array that contains hashes, or you could have a hash with arrays that are the value. That's what it is. See, when you get these nested ones, they get a little bit complicated here. And I'd model it either like this, where each sort of like piece of data has a label, like in the first example here, we have an owner, and that's an, and then the name of the owner, and then we have a pets, and then that's an array. Or alternatively, you could probably skip the labels. And if the application was small and contained enough, that would probably be okay as well. Okay, and then 5, last question here. We're back working on that first program again. Now you need to store the user's name and date of birth along with a lot of other details like their address or their credit card number or something like that. What collection do you think you'd use now? I think there's 2 options here that would work pretty well. You could use an array of hashes, where again, that all of that data has a label of some type. So you're not just having a bunch of unlabeled data in there. Alternatively, you could have a hash of hashes, where maybe you use some kind of known unique value, in this case, their social security number. You know that's going to be unique. Everybody only has one and they're all different. So you could actually use that in the key in the hash, and then you could look up somebody's data by referencing their social security number. Okay. Well done, everybody. I'm going to stop sharing that, and we're going to move right along. Okay. Sorry, my screen keeps getting messed up here. You ever heard that thing where you have 2 screens and then they're overlapping? It's a nightmare. That's what I got going on. Okay. So let's move in now to actually creating and kind of working with some of these things in code. So we're moving on beyond that sort of conceptual question of like, which one should we choose, and more into, okay, well, now how do we actually work with them? So the syntax for creating arrays and hashes is really, really similar, but there are two primary ways to create each. So the first way that we're going to look at is the most common and involves the use of either brackets for arrays or curly braces with hashes. So like I said, I'm just going to jump into IRB here. And again, this allows me to type some Ruby code and run it without having to save a file and then run a file. So let's say we have a variable X, and in that variable, we want to assign it to an array containing the numbers 1 through 5. We could just easily do something like this. We have our brackets, 1, 2, 3, 4, 5. Hit enter, and there we have our array created. We now have an array full of the integers 1 through 5. Keep in mind that we could actually place any type of object in our array. So instead of a 4, we could have like the string 4. And instead of a 5, it could be nil. And then even from there, we could create another array. Anything we wanted to do, we could do there. Just for the sake of simplicity, I showed the numbers. Okay. Creating a hash is similar, but with a little bit of extra syntax to account for the key value relationship that it contains. So let's say we want to create a hash that stores the strings A, B, and C as the keys, along with the numbers 1, 2, and 3 as values. That would actually look like something like this. So now we have X equals, we're going to use a curly brace, A, 1, B, 2, C, 3. Okay, and just like arrays, hashes can contain pretty much any value as a key or a value. So any type of data as a key or a value is probably a better way to say that. There is one important caveat to that though, which is that all keys within a hash need to be unique. So what would happen if we tried to have a non-unique key in a hash? Let's see what that looks like. So let's say we have a hash Y and we want to have, you know, 1, we're going to call that A, 2, B, and then we say, well, I actually want this key to be 1 as well. So I want to have 2 1s as my key in there. And I'm going to have that be C. Okay, we get this little warning here. Key 1 is duplicated and overwritten on line 3. And then if I go ahead and I look at what the return value of Y is, we see that my first key actually doesn't exist. It never got put in there. Again, this one overwrote it. So that's a really subtle bug. When you create that in your code, sometimes you get a warning, sometimes you won't, depending on the version of Ruby you are running. So that can be a really subtle bug in your code. Okay, now because of that uniqueness requirement and the way that Ruby implements the various data types, it is common practice to use symbols as the keys in hashes. So as a refresher, a symbol is just a type of object in Ruby. It looks a bit like a string, but it's prepended with a colon. So it might be something like this. Z equals, let's say, any word. Any word. And then if I were to check the data type or the class of that, we see it's actually, oh, I'm sorry, not Y, Z. Z is a symbol. So that's what a symbol looks like there, right there. Now, using symbols as hash keys is actually so common that Ruby provides a nice shorthand syntax when declaring hashes that have symbols for keys. So it might look like something like this. So now we have our variable A, and we have 1. And we see that creates the exact same hash with this syntax that this syntax created up here. They are exactly the same. Okay, so it's important to note that while they look really similar, symbols and strings are not the same. So those hashes look visually the same, but let's go ahead. I'm going to exit out of this. I'm going to clear our screen. I'm going to get a nice clear screen for us. And we're going to do this again. So we're going to say A equals A 1. Okay, and I'm going to do the same thing with our other syntax here. Okay, so we have these two hashes, and again, they look exactly the same. That was my point. They look exactly the same at kind of first blush here. We have an A and a 1, and a B and a 2, and a C and a 3, and an A and a 1, and a B and a 2, and a C and a 3. But if we were to compare these two hashes here, the actual difference is that our key here is a symbol, and our key here is a string. And an important thing to realize is that while they look very similar, here would be our symbol. Here would be our string, and they are not equivalent there, okay? So that's really important to keep in mind, that if you create a hash using that, this syntax up here with our symbols, when you go to reference something later, you need to use a symbol to reference it. You can't use a string, okay? So now there is another way to create hashes and arrays, which relies on using their class names and the new method. It looks like this. So you can just say array.new. And we see here we have this nice new empty array. We can do the exact same thing with a hash.new. Okay, nice new empty hash. And the important thing to know for now is that while this is a fine way to create empty arrays and hashes, the new method for both of these classes can take optional arguments that, while they're potentially useful, can have some really strange and kind of unexpected behaviors. So we can circle back to that topic at the end of the talk if we have any extra time. But my advice for right now is to use the syntax we looked at earlier, using what's called an array literal or a hash literal, where you just type the whole thing out. Once you're really comfortable working with arrays and hashes that way, you can explore using array.new and hash.new with various arguments. But when you're just starting out, those things can have some kind of shocking behaviors. Okay, we actually have our next quiz now. This one's pretty straightforward. What we're going to be doing here is some questions about creating arrays and hashes, okay? So I'm just going to launch this quiz. Each one has multiple, it's a multiple choice quiz. So there are multiple right and wrong answers for each question. All right. All right, about 70% of people have answered at this point. We're going to give maybe another 30 to 45 seconds if you'd like to submit your answers. Say 10 more seconds. All right, let's take a look at the results. Okay, so we have quite a spread here. We have a lot of agreement and one little disagreement here. I will just cut to the chase on this one, and I will say the ones that have 100% everybody agrees on, everybody's right. We have that one interesting one down there, that kind of like A that looks kind of like a symbol or something, and a 1. Let's take a look at what happens if I actually run that code. Wow, that's pretty weird. This would be the result of running that code. So that would be the value that would be returned. And as you can see, it actually does create an array, but I would say that if I had never personally experimented with this code, which why would I? Because it looks like a mistake, I wouldn't know what the result is. Really what's happening is that the Ruby engine is just trying to make sense of what you meant and trying to guess. So it creates a hash inside of that array. I would say that this is maybe a right answer, maybe not a right answer, but certainly not code that should ever appear in one of your programs, because most developers who see that aren't going to know what's happening. Okay, As far as question number 2, let's look at our answers here. We're all in agreement about the first one. It's a pretty standard hash. We're all right about that. The second one, that is interesting. Let's run that code and let's see what happens. So it turns out that is a perfectly valid hash. Although you could rewrite that with different syntax, again, where we have the A and then the colon, and that converts into a string on the back end, you can use the older syntax with the symbols as well. Okay. This next one here, this 3, 4, 2, 3, 4, 5, that's not a valid hash. Keep in mind that hashes need to have keys and values associated with one another. So you'll always see like a pair of associated values with a comma in between it. Single values in curly braces are going to throw an error. The next one is correct. We then have this A, B, C. This one's really interesting as well. I think this was worth talking about, although we all agree that that's probably a hash. Again, Ruby does some kind of like funny work in the back end here that you might not expect. And it takes what you wrote as a string and it actually converts it into a symbol. And again, we saw earlier how strings and symbols kind of look alike, but they are not the same. So again, I would never use this code, even though it doesn't produce an error, because it will look like when you read the code that you have strings as the keys, but really you're going to end up with symbols as the keys. So later when you go to try to reference a value, that's going to present a problem. Okay, final one, nil 1 3 5. Oddly enough, that is a valid hash. That'll resolve just fine. Okay, number 3, what object is this variable reference? Everybody got that right. Sometimes that really stumps people. It's just an array. It's an array, I promise. I've tested it. I can't just copy and paste the code, unfortunately, and I don't want to type it all out. But it is an array that contains a hash, which contains an array, which contains a hash. Yeah, which itself has a key that's a hash and the value is false. That's all that's going on there, but it is just a valid array. Okay. Well done, everybody. We're going to jump back into our slideshow here. And now we're going to talk about referencing, adding, and deleting objects from an array. So because arrays and hashes are just structured containers for data, they're really only useful if you know how to access and work with the objects inside of those containers. That's what a container is for. Now, this is where some of the really important differences between arrays and hashes start to become very clear. So when it comes to working with objects in an array, it's important to remember that arrays are essentially just ordered lists of objects. This means that we can reference each element of an array based on its position within the array itself. Really importantly, arrays in Ruby are 0 indexed, which means that the first element is at index 0, the second is at element or at index 1, and so on. Now, the most common way to reference an element of an array based on its index is by using bracket notation. So we're going to do that really quick. We're just going to exit out of this, clear it up, get back in. Okay, so let's say we have our array here. And again, maybe we just have, I don't know, it just has letters in it, right? That's easy enough. Okay, so we have our array. And let's say I want to reference that A. I want to pull that A out and do something with it. What I can do is I can use the name of the variable that's storing the array. I can have a bracket here and then just pass in that index. I could do the same thing if I wanted B. I could go like this. Pretty straightforward all the way through. Now, you can use these references really similarly to how you might use a variable. They're essentially pointing to the object in your computer's memory. So you could even do something like this. You could say array 0, which I know that's going to give me an A because I know it's in that array. And then I could go, I don't know, what's a word that starts with A? Albatross. Albatross starts with A. And so then I get albatross is what that resolves to. You could even take that return value and then you could assign it to a variable. So I could just take this and I could say, I don't know, large bird. And then when I reference large bird, I just get albatross. I no longer have this kind of funky bracket syntax in there. Okay, now a common mistake that beginners make is to look at an array and say, all right, so we have 4 elements here, and I want to reference the last one. So I'm going to do something like this. Not the expected result. Again, that's always going to return nil because there is no index 4 in that array. Arrays are 0 indexed, so there are only indexes 0 through 3 in that array. It's always the length of the array minus 1 is the final index. So in addition to single elements, bracket notation can actually be used to reference multiple elements at a time. There are 2 ways that you can do this. First, you can specify a range of indexes that you'd like to reference. So we could do something like this, ... 3. So what this is going to do is return the array containing the elements from the original array at index 1, 2, and 3, because that's a range of 1 through 3 inclusive. So note that I use 2 dots there in our little range. That's the syntax for what's called an inclusive range, meaning a range that includes the final number, or in this case, the final index. So for an exclusive range, you can actually use 3 dots. So we could rewrite this with 3 dots. That's an exclusive range. It's not going to include the final index. And then the other way to reference multiple values using that bracket method is to use 2 numbers separated by a comma. So the first number is going to be the index of the first element that you'd like to return. And the second number is going to be the total number of elements that you want to return, working sequentially from that first number you referenced. That sounds really confusing. It's not. Let's look at it in like an example here. We have 1, 3. That's going to return 3 numbers starting at index 1, or 3 elements starting at index 1. And if we did 1, 2, you get 2 elements starting at index 1. And if we did 0, 4, we get 4 elements starting at index 0. And now the final thing I want to look at with regards to this kind of bracket notation is the use of negative numbers. It can be very, very useful to solve some types of problems. Now, essentially, you can reference objects from the right of the array by using their negative index, so by the end of the array. So importantly, there is no negative 0. So the final element in any array is referenced with negative 1. The second to last can be referenced with negative 2, and so on. So we could do something like this. We have array negative 1. That's going to give me my D. That's my last one. We can do array negative 4. It's going to give me A, or the first one. It's also possible to use negative numbers within a range. You could say, give me an array, give me starting from index 0 all the way up to negative 1, which is, again, the last one. So you get the whole array. You could say, give me an array starting at index 0, going all the way up to index negative 2, which would be the second to last one. And that would work just fine there too. Okay, so that's referencing objects already in an array, but how do we add and remove elements? Honestly, there are a ton of ways to do this. So we're just going to be focusing on a few of the most common methods that you're likely to run into, because there are a lot of them. Keep in mind that we're looking at modifying the existing array. We're not creating a new array or reassigning the variable that references our array. So we're only going to be covering destructive methods which modify that array object in memory. That's a really important concept. So I'm actually going to, once again, clear this out, which is a 2-step process, unfortunately. Okay. So I'm going to reinitialize our array. Perfect. Okay. So to add an object to an array, you can use the following methods. You could use insert, which essentially takes 2 arguments, which is the index where you'd like the object to be inserted, and the object itself that you want inserted into the array. So we could do this. We say array.insert. And I would like to put something at index 1, and I would like that thing to be the word hello. Okay, I get that return value here, and then if I were to reference my array, I see now that I have a hello at index 1, and the B just gets shifted over. So the thing that was at that index doesn't disappear or get overwritten or anything, it just moves over. So while insert allows you to be specific about where you're inserting the new objects, there are built-in methods that allow you to add an element to the beginning and end of an array, which is a really common task. So if you want to add something to the beginning of an array, you can use what's called the unshift method. So you can go array.unshift, and you can just say, let's put true in there. It just take the argument that you put in is just going to be put at the beginning of the array, as we can see there. So now we have true at the beginning of our array. Unshift has an alias, which is known as prepend, which I think is a much better name. And it does the exact same thing. Let's say we now want another A in there. So now we have an A at the beginning. Our other A is still there, but that first A gets put in the beginning there. Now to add elements to the end of your array, you can use the push method. Very, very, very common. Say we want to put the number 109. And as we can see here, it's just at the end now. It has an alias called append. Again, I think a better name. And it just does the same thing. It just takes the argument and sticks it on the end of the array. You also have this like cool little thing called the shovel operator, which is actually a method and not an operator, but that's beyond the point. And it performs the same function of adding an object to the end of the array. It looks like this. Let's say now we want the symbol hello to be put in there. Oops, I'm sorry. Two of these guys. Oop. And we can see that our symbol hello is here now. So now to delete elements from an array, you have a variety of methods as well. First, you have delete and delete at. Delete takes an argument, which is the object which you want deleted from your array. So let's say array.delete, and I want to get rid of the letter A from my array. Okay, so it's going to take that argument out and return it to you. So note that delete will delete every value from your array that is equal to its argument. So if I look at my array, I used to have two A's in there, one in the beginning and then one at index 2. Now I have none. So that means if you have like 5 letter A's and you call delete A on it, it gets rid of all of them, which may or may not be what you want to do. Delete at is somewhat similar, but it accepts an integer as its argument and it deletes the element, the element at that index in your array. So we can say array delete at. And let's say we're going to delete whatever is at index 2. It's going to take it. It's going to return it to you. But then if we were to look at our array, it's no longer there. What was that? Yeah, letter B. Yeah, fine. Okay, so additionally, if you want to delete the first element in the array, you can use the shift method. No argument necessary because it's just going to delete whatever is first. It's going to return it to you. So our true is gone now. And then if you want to delete what is at the end, you can use the pop method. And again, no argument necessary. It's just going to delete the last element in the array. So we look at our array here. And again, all of that stuff that we had just specified is gone permanently out of the array. So I know that was a ton of content. So I actually created a nice little summary sheet that we can kind of go over really quick. So here's our summary sheet. I recommend that you take a screenshot of it. It is, I think, pretty useful. And what we're going to do now is take a minute to kind of look over this summary sheet. I'm going to leave it up while I post up a quiz about adding and deleting things from an array. Oh, also referencing objects. All of that stuff we just covered is going to be on this quiz. So the way that this quiz, I'm going to launch it right now, and then I'll kind of explain it. We have this one array at the top. It's a very simple array. It has the numbers 1, 2, 3, 4, and 5 in it. And each question is about that array. What are we going to return with certain little snippets of code? Okay, we're about 50% answered now. I'm going to wait another 20 to 30 seconds. If anybody out there who hasn't answered yet, you got 2 people wants to wants to take a shot at some of these, and then we're going to go over them real quick. Oops, I'll leave that up for you. Okay, I'm going to close it. Here we go. Okay, the results should be on your screen now. Let's look over these really quick, shall we? What does array or R1 return? Yeah, 2. And again, that's because arrays are 0 indexed. So index 1 is actually the second element of the array. Well done, everybody. What does R5 return? 0, for the same reason. Again, there is no index 5 there. We have 5 elements, which means the largest index is 4. Well done, everybody. Okay, how could you delete the integer 5 from array? Let's see, r.delete 5. That would do it. And r.pop would also do it. Awesome, well done. And number 4, how could you add nil to the end of your array? Yep, you could use that cool little shovel operator, really a method, shovel method, maybe we should start calling it. And that is really the only way, because if you look at the pop method there, pop is used to delete and it doesn't accept any arguments. So you cannot actually add to the end with pop. Okay, well done, everybody. Let's move on to hashes. Man, screen just gets so messy. Okay. So now that we have a pretty good handle on array, we're going to look at referencing, adding, and deleting objects from a hash. A little bit more complexity built into working with hashes. So the most important thing to remember here is that unlike arrays, hashes are not indexed lists. They are collections of key value pairs. So that means that our method of referencing elements based on their position within that collection is not going to work for hashes. So in order to reference a value in a hash, we have to reference its key. Okay, let's look at an example of what that might look like. So let's say we have this hash here, and I don't know. We're going to rely on this classic one, huh? Okay, there's our hash there. We have all of these symbols. They're associated with the numbers 1 through 4. So let's say I want to reference the number 1 here. I could use bracket notation, and I could pass in the key associated with that. And that's going to return the 1. I could do the same thing. If I want that 2, I just reference the key that is associated with that value, and I get that 2. Here's where that whole thing I said earlier about strings and symbols not being the same, here's where it pays off. Notice that I have this little colon here again, indicating that I'm talking about a symbol. What if I just skip that and I just say, well, I know I have a key of A. I get an error because essentially what Ruby is doing is it's looking for a variable called A. That's variable reference. I don't have a variable called A, so it says, I don't know what you're talking about. Here's an error. Okay, what if I do string A? So I put quotes around it because again, an A is an A, right? An A is not an A. You get nil, and you get nil for the same reason that referencing beyond the end of an array gives you nil. It's because we don't have a key with the string A in it, in this hash rather. So nothing is associated with the string A. Okay. So if you want to return a key based on the value it's associated with, you can use the built-in key method. So we have our hash here, and we can say, well, give me the key that's associated with 1. And we can see that we get our symbol A there. We do the same thing with 2 when we get our B, no problem. Now, you do have to be very careful with this method though, because unlike keys, values do not need to be unique. So that means you might have several keys, different keys, that are all associated with the same value. And that hash key method is only going to return the first occurrence of a key, which has a value equivalent to the argument that you pass in. So if you had a whole bunch of letters and A is associated with a value of 1, and Z is associated with a value of 1, and T is a value associated with a value of 1, and you say, well, give me the key associated with 1, it's only going to give you A. It's only going to give you the first one. Okay. So as far as adding new elements to a hash, you can use just simple assignment. Let's say that we want to add a new symbol E key to our hash and associate with a value of 5. We could do this. That's a 3. There you go. And associate with a 5. And then if we were to reference the hash here, all the way down here at the bottom, we see that we now have an E and a 5 down there. And if for some reason you wanted to add a new true key, like the Boolean true, to our hash, and we want to associate with the letter Z, we could do that. And then if we look at our hash, we see that we have this weird kind of looking key over here, but it all still kind of works. And keep in mind that you have to be careful with this technique because you can't have repeat keys. I'm going to keep emphasizing that. If you attempt to add a non-unique key to a hash, the existing version of that key is just overridden and reassigned to a new value. So if I want to do something like this, hash, let's say, oh, I want to add another A, and I want this one to be associated with 109 for some reason, and then I look at my hash, I don't get another A at the end. This original A is simply overwritten. Now, as far as deleting key value pairs from a hash, the two most common methods are delete and delete if. Delete takes a key as an argument and deletes both the key and the value associated with it from the hash. So you could say hash dot delete. It's a delete whatever is associated with the B, I guess. Okay, so it's going to return that value, but then if I look at my hash, both the key B and the value 2 are gone. Delete if is really similar, but more versatile. Delete if accepts a block, and it deletes any key value pair from the hash for which the block evaluates as true. If you haven't worked with blocks before, that's totally fine. It's a little bit complicated, and I'm going to show you some examples. I think you'll get kind of the idea. So let's say we use hash dot delete if, and then we have our key. That's not the right syntax. We have our key, our value. And let's say delete if the value is greater than 100. And we get an error. This is an interesting point about blocks. So let's look at our hash and see what happened. Okay. So our key value pair that was associated with a value greater than 100 is gone. So that first one is gone. That's really interesting. Let me talk about how delete if works a little bit and how we got that first one deleted and we still got an error. So essentially what delete if does is it goes through each key value pair and it sort of like passes it into this block as an argument. And it says, okay, well, is this value greater than 100? Yes. Okay, we'll delete it. Is this next value greater than 100? No, keep it there. Is this value greater than 100? No, keep it there. How about that one? No, keep it there. How about this one? Z greater than 100, that's nonsense. Here's your error. So that's what happened. It actually executed on each of those key value pairs, and it got to that last one, ran into a little bit of logic that didn't make sense, and threw that error. Okay. We could do something like this. Key value again, and we can say if the key is equal to true, let's delete that. Yes, I did mean delete if, not delete is, because that's not a method. And we see here, we look at our hash now. Geez, sloppy typing. If we look at our hash now, that last true Z is gone. Okay, so again, that was a lot too. Let's take a look at the little summary I wrote up, and then we can test our knowledge with a quiz. There's our summary if we want to kind of take a glance over at that. And I'm going to post up the quiz. This is our final quiz of the night. And after this, it's just Q&A. So let's take our time here. All right, we're gonna give another, let's say 30 seconds. 30 seconds for the remaining few people out there who have not submitted their answers yet. Mm, 5 seconds. Anybody else? There's two of you who, oh, hey, awesome. And okay, I'm gonna end it. Here we go. Okay. All right, let's take a look. We're gonna go through here. What does hash A, the string A, return? And everybody got that right. That can be a little bit tricky, but I hopefully made the point. Strings and symbols are different. There is no key of A in quotes in there. How can we add the following key value pair consisting of F in quotes, so a string, to the key and 6 as a value? Okay, we have a split decision there. The correct answer is the third answer, because again, I specified F, the string, in quotes, not the symbol F. So yeah, that second one is actually going to add the symbol F, which is not what we're looking to do. What happens when the following code is run? Hash true equals nil. Let's see. Most people said the key of true is added to the hash with an associated value of nil. That is correct. The key of nil is added to the hash with an associated value of true. Those things are flip-flop. So the key is that first thing, the value is the second thing. Okay, and then finally, how can you remove the value of 3 from the hash? Delete C would be the I think most obvious way to do it. These other two answers that somebody said yes to, I think are kind of interesting. So reassigning the symbol C to a value of nil, is that deleting 3? I don't know. That's a good question. There's no 3 in there anymore. I think that's kind of up to interpretation. This other one, hash delete if key value key equals C. Let's run that code because I think this is kind of interesting. Okay. Cool, we have our hash now. So let's say I run that code. Key equals C. I check out my hash and it's empty. That code deletes everything. So first of all, technically true. It does remove the value 3 from the hash. It also deletes everything else. Now, why does that delete everything? Okay, and the answer for why that deletes everything is this section right here, key equals C. And that honestly was a typo the first time that I typed up this quiz. And then I only realized it when I ran this workshop for the first time, but I kept it in because I think it's interesting. That's a really common error that people make, is when they're trying to do comparison, which can be either 2 or 3 equal signs, depending on the type of comparison you're doing. And instead they put assignment in there. And just because of a quirk on how blocks work, assignment is going to return the value of the thing that is the array, or the variable is being assigned to. So it returns that value. So in the case that that's a truthy value, and if that doesn't make any sense to you, don't worry about it. That means that that block says, oh, well, that's true. So on each iteration, it took the key, it assigned it to C, said, well, that's a true thing that I just did, and then deleted all of those pairs. So kind of related, kind of not related, subtle bug to look out for. Okay, everybody, that was the workshop. Thank you for sticking in there with me. We actually picked up quite a few people as we went along, so I hope that you were able to follow along, even though we started out without you a little bit. I'm going to be here for any questions. You can use the Q&A function below if you'd like to ask me any questions. In the meantime, I'm actually going to be over here. I'm going to grab our feedback form. We request feedback from everybody who takes these things, and I read it, and I do my best to take all of the feedback under advisement. I do take it seriously. So that's what it looks like. You don't need to see that, though. I'm just grabbing the link for you. So if you would like to provide feedback for me, I would appreciate it. You can fill out that form. It'll take you 2 or 3 minutes. No big deal. I just posted it up in the chat. Also, I'm hanging out for Q&A. If anybody has any questions about any of this stuff or kind of related stuff, I'm here for it. So. Oh, you're right. I did not, my settings were wrong. My settings were wrong. Sorry, everybody. Yeah, so the default settings are that when I type anything into the chat, it only gets sent to the host, who's me. Visually in the interface, I see it because it's sent to me, but it doesn't send to you guys. It's a terrible, I don't know why that's the default. Sorry for that. I have to go manually change the chat settings in order to chat with somebody who isn't me. No questions over all this. We talked all this about hashes and arrays and deleting stuff and blocks and all that stuff. No questions at all. Okay. It's totally fine. All right. Well, I hope you guys found that useful. You all found that useful. Thanks for coming out. I appreciate it. I'm going to take off. I'm used to sitting here and answering questions, but if there aren't any, adios, Tyler. Absolutely. Thank you for coming out. I hope you found it useful. Iljan, same to you. Thanks for, you guys were the OGs. You were the first 2 here. So thanks, Jazz. Everybody take care. I'll see you another time. All right.